So welcome. I'm super happy to be here at Warsaw, in Warsaw at WarsawJS. So my topic is about cross-platform testing in React Native. But this topic will, let's say in the middle, change a little bit because we are going to explore something totally new, a new approach to testing in React Native, which doesn't really involve like existing solutions, but instead we will use something brand new. So before we start, I want to say a couple of words about myself. So I'm Szymon. I'm from Toruń, so the city of gingerbread and Nicholas Copernicus. I'm currently working at Callstack Incubator, which is basically an internal team of people messing with technology, basically. So our job is to try to push React Native as much as possible in the future, create new tools, new libraries. For example, right now I'm working on providing a way to create live activities. You see on your iOS devices these notifications-like things in visible at lock screens. So yeah, I'm working on making it possible to use JSX, so basically use React Native to develop them. And if you want to be up to date with my research, with my findings, with my libraries, you can follow me at GitHub, and the second link is for X. So without further ado, let's start with the topic. So if you are a React Native developer, you know that testing is not easy for us. Why? Because we are in this weird world when we write our apps with JavaScript, and we can use JavaScript-based tools for testing, like Jest, for example. But on the other hand, we have those like end-to-end testing solutions which are capable of testing our apps from the perspective of an end user. So basically, we are simulating user going through our app, pressing buttons, writing stuff into inputs. And both ways have their own advantages and disadvantages. So let's start with JavaScript-based testing. So this is pretty much something you all, not even React Native developers, but you all as JavaScript developers have probably experience with, because I guess you all write tests, right? And you all use, for example, vtest or Jest or I know Jasmine or whatever, Karma, for example. Do you remember Karma? It was like 5 years ago, 10 years ago. But yeah, you need testing via Jest, for example. It's super fast, under milliseconds. What else? Great developer experience because you are using JavaScript to write tests. You have before each, describe after each, so effects are easy to be handled. You can spy, you can mock. Well, you can do pretty much everything. But the problem is those kind of tests run in Node.js, so you cannot really, for example, in case of React Native, you cannot access native views. They are not there. Everything is emulated. So for example, if you have your component and you have, for example, a second component visible above it, and you make a mistake. So the view above it is obscuring the underneath view. So you cannot press it in practice. But in this kind of test, it will work because there is no layouting. There is no event-based, no gestures system. Like you cannot really test gestures. But on the other side of the world, we have end-to-end testing tools, which are super great, super fun. But on their side, we are not testing our components. We are not testing our functions. We are not testing our modules. We are testing the app. So first of all, we need to switch our mind to basically, we should write those tests from the perspective of an end user. So user opens our app, goes through some screens, presses on some buttons, and some information is supposed to be shown to this end user, which is okay for testing the apps. But for example, if we are writing a single component or we are writing a single function, or for example, we are creating a native module for React Native, this kind of tests are not like pleasant to work with because we have no app. This is a module. So we need to create the app. Plus, those kind of tests run in real environment. So you need to run emulator, you need to build the app, you need to like put all the UI elements on the screen, you need to press them. So basically, it's not the best experience for us as developers of, for example, native modules. But we as React Native developers, we kind of learn how to deal with it. So we are using both JavaScript-based testing and end-to-end testing in different scenarios. So if you are writing some like components, like simple components, we can use JavaScript-based testing for asserting that certain props work correctly, for example. They usually run locally because they are fast. And obviously, we are writing them, right? We are all writing unit tests, right?
Yes, sir.
Yep. So, always, that's the best. Yep. So yeah, developers are writing those. But on the other side of hand, we have those end-to-end testing tools, end-to-end tests, which are slow, which usually take about 20 minutes, 40 minutes, 60 minutes, even a whole night in some cases. So usually when we have end-to-end testing suites, we run them in CI/CD nightly, so they can basically take the whole night, and in the morning we can see that, oh, it failed for some reason. And usually we are not writing them as developers. They're written by special QA engineers which know what they are doing and what to, for example, assert on the screens. But like I teased in the beginning of the presentation, this talk is not really about unit testing and not about end-to-end testing. Because there's a third way, which allows you to kind of get the best of the two worlds, best of JavaScript-based testing and best of end-to-end testing. So my question is, and I don't expect many hands to be risen, but have you ever written a React Native module? Single? All right. But I guess many of you seen React Native and use it, right? So you know that if you write a React Native application, you need to install certain native modules, and usually this is a pain. And writing a native module and testing it is also a pain. So do you know this guy? Have you ever used React Native MMKV or React Native Nitro modules or React Native Vision Camera or some more like Nitro modules? So this is Mark Rusavi. He's well known in React Native community for, well, creating a lot of fun libraries to play with. And he knows the pain. He knows that you need to create an example app, you need to fake some UI elements in order to be able to interact with your native module and test it. So his approach is that, or like everyone approach is that first, if you are creating a native module, you need to learn new tools because you usually don't write end-to-end tests. So you need to learn, for example, Maestro or Appium or Detox or whatever else you use for end-to-end testing. You need to learn new DSL, new way to write tests. For example, Maestro uses YAML, so this is totally a new thing. You cannot use JavaScript. And then in the end, you need to create this example app, which will allow you to fake your native module being used in some existing application. So for example, in Maestro, we are building something like this. So in case of MMKV, this is basically a key value store. So we need to write into the store and get the same value from the store. So on the left side, you see basically Maestro scenario for doing exactly that. You need to find an input. You need to put something in the input. You need to tap on something which will basically, under the hood, call the save method on MMKV instance. Then you need to click the second button to read from the MMKV instance, and then you need to assert that something is visible so that our WarsawJS input was really written to MMKV and was really retrieved from MMKV. And this all for the single function and single case. And this is not really a good experience of native developer because we are trying to use tools built for QA engineers. We are basically trying to test our functions, low-level functions, low-level modules, libraries which are supposed to be used by developers from the perspective of simple users, which is not great because like the main principle of testing is that we should test our code from the perspective of an end user. And in our case, end users are developers. So we should be testing our code from the perspective of a developer and how our developer uses our code by executing functions in the JavaScript. So it would be great to use JavaScript to write those tests because that's the way how our, let's say, clients or consumers or users in general will use our libraries. So that's why I created Harness or React Native Harness, which is basically a way or a try of mixing best advantages, best details, best features of Jest-based testing, JavaScript testing, and end-to-end testing. So the result is something like this. If you know Jest, if you know vtest, you know that this is basically a Jest test, but the difference is that the import statement is coming from React Native Harness. Describe is here, before it is here, it is here, expect is here, and matchers such as to be are also here. And if you run npx React Native Harness with your emulator running in the background and your app ready, you will see that basically the app will be running in a second, and yep, you will see the splash. But under the hood, your JavaScript written tests are being run on a real device. So you can, for example, run them on an emulator like this in your CI/CD locally, or you can use a physical device if you have it connected, for example, via ADB to your machine. So Reactive Harness, like I said multiple times, is trying to get best of both worlds. So it gives you tests with full native access to any module, to like a full React Native environment in a real device, basically. So layouting is here. You can use different native modules. You can, for example, interact with the operating system, but still you don't need any UI automation. It's just JavaScript and works. Internally, it uses Jest, so we get the same CLI experience as with Jest. All the reporters work just fine. Code coverage works just fine. And the only bad thing is that you still need to build the app, because that's something like even native developers writing native modules need to build their code. That's something we cannot really omit in any way. So how Harness works under the hood, if you're interested in. So now deep dive into how Harness works. First of all, if you know how React Native applications are being made, you know that there is a Metro bundler used in them, which is basically Facebook's equivalent of Webpack or Vite or whatever, or Parcel, for example, if you have ever used Parcel. So Harness uses Metro to basically bundle your tests. So from the perspective of Metro, tests are being converted into JavaScript code that's basically consumable from the perspective of a JavaScript engine working on a real device. And then when you start running tests via Harness, it basically tries to hijack your app. So if your app is starting, it's asking Metro for the index.js file for the entry point, and Harness is like, no, this is not the file, you need to use mine. And basically, a runtime JavaScript code of Harness is being injected into your app shell. So the native code is the same, but runtime is totally different. And then at the end, when all tests are done, all like errors are written in the memory, then runtime can pass this information back to the CLI for reporting and further work. So in order to run Harness, if you decide that this is the day I want to use Harness in my app, the first thing you have to do is to create a config file. I think runners are pretty much self-explanatory, but when it comes to entry point and app registry component name, it's not that, let's say, simple to understand what's exactly the meaning of them. So entry point is basically a path to your index.js file. It's usually index.js file. It can be different. For example, if you use Expo and Expo router, it will be Expo router. In case of Expo, you have package.json. In package.json, you have main property. This is usually the main property. The second thing is the name of your app. If you have ever built React Native application, you know that you usually call app registry.register component with a name and component. So this is basically the name you provide. Why? Because Harness needs to know which what's the name expected by the native code, so it can basically inject itself into the place of a real app. And then when it comes to runners, we have Android platform and Apple platform. So basically 2 operating systems. Harness also supports Vega OS, the new OS by Amazon, used in their Fire Sticks, I guess. And the plan is to also introduce web at some point, so you will be able to test your components, for example, and your code in all the basically all platforms available for React Native today. And of course, you can see that as a device, I'm providing Android emulator and Apple simulator, but there's nothing stopping you from using Android device and providing the name of a device. So if you have it connected to your PC or MacBook via ADB, Harness will basically communicate with this device and run your tests on a real device. The second part you need to do is basically instruct Jest that you have Harness tests in your config, in your project, so it will not try to run them. Because Jest is, I don't want to say stupid, but it basically takes everything that's ending with test.js and it tries to run it. So we need to say that, okay, we have those harness.js files, and those files are supposed to be run via Harness. So that's why we are providing a second project with a second preset coming from React Native Harness, providing the glob pattern to Harness. And the nicest part is that with the knowledge of how to write tests in Jest, you know how to write tests in Harness. Because you know how to use test, describe it, it.each, it.skip, it.only. Everything is working the same way in Harness. All the lifecycle helpers are working just fine. So before all, before each, after all, after each, you can use them just like in Jest. Matchers are also the same. You can use the same matchers. They work in the same way. Basically, under the hood, Harness uses vtests implementation of matchers. So everything that works in vtest will work in Harness. And when it comes to mocking, it's a little bit limited because Metro is different than Webpack, for example, and certain features of mocking needs to interact with the module system of a platform. But you can spy on things and assert that certain functions were called with certain values. Plus, you can also mock modules. So if for some reason you want to mock something out, you don't want to allow your module to, for example, display some overlays like asking for permissions, for example. So you can mock the permission module out and just place something like promise resolved, and that's it. So getting back to Mark Rusavi, the story is that I needed a real life example to test this thing out, because okay, it worked in my like closed source, super easy, super simple examples, but I needed confirmation that it can be run in practice. So I took React Native MMKV. I implemented Harness in it. Then I asked LLM, hey, friend, can you generate 20 tests about writing to MMKV and reading from it? Please use Harness. And it created tests. I ran them. 2 failed. There were 2 bugs in MMKV, which were never found up until this moment because, well, the scenario for testing in MMKV was like, I need to save something, I need to read something, it should be the same. And that's pretty much it. But with Harness, we could introduce tests like, if I try to write a value to a key that's empty, empty string, it should fail. And it didn't. Like it tried to save, it didn't succeed, but still there would be no exception thrown. So from the perspective of an end user, it would seem that the key was successfully saved, but in reality it was not. So hardness is working in React Native MMKV to this day, and from what I heard from Mark, he's really happy with the experience. So that's probably the best way to make you use hardness in your projects. But I know that testing native modules is not something everyone will do. Not everyone is writing native modules. Sometimes people are just writing components. And like I said before, when you write components in React Native and you try to test them via Jest, you have no layouting in place. You have no gesture system in place. So even though your tests succeed at the first glance, in practice, it may be that they are not clickable, for example, because there are some layouting issues, some gesture system issues. So in the future, hardness is supposed to also handle component-based testing. So you will be able to test, like to render a single component. I think it's not looped. Okay, so if you watched closely, there was a component shown in the center of the simulator. And via hardness, you could basically simulate presses, simulate gestures, swipes, scrolling. You could wait for some element to be visible, or after it's not visible after some time. So basically, everything you could do with React Native testing library will be soon possible via hardness in a real environment. This particular example was showing up the snapshotting feature. So technically, hardness can take snapshots, take images of your components and compare them with previous runs, so there's no visual regression involved. So finishing up, I want to thank you, Mark Grusai for sure, for letting me play with hardness in React Native MMKV, and I broke several things along the way, so it was nice from him to not, like, I know, throw me out of the repository. And obviously, thank you to Mike Grabowski, the CTO at ColdStack, for letting me work on hardness, because I'm doing it like it's my job, day-to-day job, to work on open source. So thank you, Mark, for letting me work on hardness. So if you want to run hardness, if you want to play with hardness today, you can scan the QR code, you can write down the URL. You will find all the necessary information in here. We've also ready to use recipes for CI/CD in GitHub Actions. If you have any issues, there's a Discord link. I'm here to help you, so don't be afraid to reach out to me. Obviously, you can see my social accounts again. And that's pretty much it. I have my fingers crossed that starting from now, if you don't write tests in Jest, because I know not everyone writes them, I'm not a fool. I know how it is. Maybe you will use hardness, so you will be sure that in practice, your components, your modules work like they are expected to work. Thank you.
Thank you, Szymon, for your talk. And it looks like it's really worth it to start using hardness, or at least to try it out. Do we have any questions from the audience? Yeah, just checking if. I know. Yeah, you were first. So.
Okay. Yeah. Thanks for an interesting talk. I think I've seen you on the like a React Nation or something. From
most likely, yeah.
Yeah. So just curious, how well hardness is suitable for a scenario, let's say, when the tests help you to write the feature? I'll give a bit more of a context. We used to have a project based on Cypress where we wrote tests along with the functionality. It was like a preview thing. Let's say you need to click 3 things to open a specific view, which has some specific data. And then the test you write along with the feature. And so the watcher restarts everything and then just do the assertion, and you get the immediate feedback. And only those tests kind of stay. So the question is, like, how fast is the refresh on watch? And do you watch also changes in related both tests as well as modules? And the second is there some way to kind of have the proxy on HTTP level, like in Cypress? I don't know if you were like, because ideally you want to do proxies not on your code level, but somewhere else. And yeah, just curious if there is something.
Yeah, so starting with the watch mode, it will restart tests on both cases. So if you edit your app files, it will restart. If you edit your test files, it will restart. And as long as you don't need any changes in the native code, it's basically like just. So the app is basically closed, started again, the test is being run, and then it waits for another round. Basically, if you change something, it will start over. If you need to test, if you need to change something in the native code, then it's a bit more complicated because you need to rebuild. So, sorry, that's the how it is right now, and we can't really do anything about it. So that's the first one. The second one about doing some kind of like HTTP interception, I guess, something like that. Right now, it's not supported. Technically, you can do the same thing on the JS level, on the device side, because in React Native, there is this like hidden feature in the code that if you import some cryptic constant module from cryptic React Native /something/something/something, you will be able to intercept all the calls happening.
From test. The thing is that in test, you kind of provide the mocks and then you verify with the test. That's the
Technically, like, right now, it's not included in harness, but technically it's achievable without like going to run some proxy server on in Node.js, because like I said, you have this like hidden React Native thing which allows you to intercept calls. So like for example, React mock service worker, that was the name of the library, MSW. Yeah. So in React Native, it's using basically this hidden thing I'm describing. I think it's interception, something like HTTP interceptor, something like that. So technically, you can use it yourself in your tests to basically write responses. Yep.
All right. So you mentioned a couple of times between. So it is. You said. I think you said it is a custom Jest runner. However, you are using the matching APIs from Vitest. So what? My question is, what is actually under the hood? Is it Jest or is it Vitest? And if it's Jest, why not Vitest?
It's complicated. It's complicated because the first idea was obviously to basically reuse everything that's already there. So reuse Jest, test collection mechanism, so all the implementation for describe, test, before each, yada, yada, yada. The problem is that certain functions in Jest assert they are running in Node.js. They import from Node.js packages, which are obviously not present in React Native. So I couldn't do that. So then I realized that, okay, I can provide a Jest runner, a custom Jest runner. And if you write your custom Jest runner, it's up to you to run tests. It's up to you to collect tests from your files. So basically, I rewritten the whole like front-end API. So all the APIs for describes, before each, before all. So I gather all the information I need, and then I pass the information back to the CLI. I'm starting to execute test named something, something, something. Oh, it failed with this error, or it passed. And then CLI is able to basically display this information. So I couldn't use what's already there because it's depending on Node.js. I had to rewrite it from scratch to be able to run it in React Native.
Okay, so it is Jest under the hood, not Vitest, ultimately.
It's Jest, right?
Okay.
But parts of like implementation, because initially I started to rewrite matchers by myself, and then I realized there are like 200 of them, which is not really a maintainable thing for a single person. So then I realized there's Vitest, and Vitest has 100% compatibility with Jest. And it turns out that Vitest is not dependent on Node.js at all. So that's why I'm using Vitest, basically.
Okay, so matchers from Vitest.
Matchers from Vitest,
okay,
yeah.
Awesome.
Expect from Vitest, and I think, yep, that's it.
Thank you.